favorite category, the meats and proteins. And I should say right now, when I was doing my thesis work, I was a vegetarian, so I wasn't eating any of this, but it was still my favorite. So when we think about food forensics, there's two sort of categories of questions that most people are asking. Is it authentic? Does that mean, does it fit the label? Can it be verified? Was someone lying to me and taking my money and I was paying for something that I wasn't getting? Or where did it come from? And sometimes you actually want to verify an origin claim, but really if we kind of break it down into rough categories, it's authenticity versus origin. So we can use some likelihood-based data interpretation approaches to try and get at some of these questions, and this is sort of the new frontier in food forensics. For a long time, we just analyzed a whole bunch of isotope ratios and shoved it into some sort of principal components analysis and just said, what do we get? Which is sort of this discrete approach where you're trying to fit something into a certain number of groups. Does it fit or not? We're moving into, and I'll show a little bit of this, the sort of continuous approach or this predictive approach. Where are you potentially from when all of these possibilities are open to you? So again, this discrete approach, or just do you fit or not into a group, is where a lot of this has been for the last couple of decades, and we're just starting to move into different approaches. So this is sort of what this looks like. This is an example of chickens. These were raised in Brazil, most of them. So what you see are, we had a group of chickens. This was data set that someone provided to us, and they had chickens that were raised in a barn, so sort of that battery, the typical traditional way of raising chickens, and then those that were free range. And those data sets were split in half. So one was used as a training data set, and then we actually tried to assign the remaining samples to see if they actually fit in their correct group, since we knew where they should belong. You can see we did fairly well. We had one assignment error there, where one of the free range chickens actually looked as if it was barn raised. So the question is, was just an outlier? Did someone actually mislabel something, or was someone not telling the truth? And then the gray dots here are actually samples that I collected. This is chicken meat that I collected from grocery stores in the United States. So not Brazil, the US, but just curious, using carbon and nitrogen, do they fit with either of these Brazil groups? And the answer is they look mostly barn raised, which is probably not a surprise when we think about where most of our chicken comes from in the United States. So this is how traditionally a lot of the authenticity work has been done in food forensics. Okay, now we're going to go talk about my favorite study animal, the hamburger. And why did I spend so much time in my thesis thinking about hamburgers, particularly McDonald's hamburgers? This is the world, and each country has been resized by how many McDonald's restaurants there are versus population. So the more McDonald's restaurants there are per capita, the larger the country, okay? That's Japan, that dark purple one right there. That's Africa, the little skinny, I don't think I have a pointer, I can do interpretive dance. Maybe I do. Do I have, what is? Ooh, look at that, okay. This is South Africa here. Now this data are from 2004, so things have changed, of course, as globalization has gone on, but in the US, we have at least access to a lot of fast food and a lot of hamburgers. So it seemed like the perfect study system for the American diet, right? So the questions that I was asking, does anyone remember this ad campaign? I'm starting to date myself here when I throw some of these up. But it's not just where's the beef, but where's the beef coming from? That was really what I was interested in looking at as part of my thesis work here. So, working with some collaborators out of Brazil, we collected McDonald's Big Macs from the US and around the world, delipified them, so this is dry, defatted meat that you're looking at. We're looking at the carbon isotope ratios here of those samples versus the cumulative fraction in the population. So in other words, if you look at a minus 20 per mil, about 45% of the samples fell below that cutoff. Make sense? You guys have seen these figures before. So we could define sort of some end members here as England and Scotland, which fed their cows, all had grass-fed diets, versus Brazil, which had a whole bunch of C4 in their diets, mostly C4 grasses. And you can see that everything else, the global data set, there were some samples that were primarily fed, some beef cattle primarily fed C3 plants, and others that had a lot of C4 in their diets, okay? So if we want to now turn that into an estimation of diet, we need a model. So here's our model that we pulled from the literature. This is a feeding study where a group out of Europe fed cows varying amounts of, so this is the lipid and this is the protein from these cows that were fed varying amounts of carbon that came from corn in their diets. And as the percent of corn increased, the delta 13C values increased. Not surprising, that's what it's supposed to be. But now we can predict how much C4 was in the diet or corn was in the diet looking at our McDonald's hamburger samples, our Big Macs. So here's what it looks like. This is the cumulative proportion, and I've got a typo, forgive me on that one. It's not a Big Mac, it's a Big Mac. Proportion of C4 in the hamburger patties for all these different countries. And of course, because Brazil was one N member and England, Scotland were the others, they have 0 and then 100%, and then everything else falls in between. Here we are in the US. So lots of C4 in our beef cattle diets, probably not surprising. Then you get some place like Japan. What do you think is going on there? There's a lot of C4 in those cows' diets. How much C4 is growing in Japan? Not a lot. So what's going on there? Imports. They import a lot of stuff from Australia and South America. So this is a publication that came out in 2011 with these researchers, and we coined the term glocal, which is the idea of we're eating a globally produced, globally marketed food item. In other words, you can go into restaurants around, McDonald's restaurants around the world, and you can order the exact same thing, a Big Mac, that looks the same, but isotopically it can be very, very different because it's using local food resources or it's relying on the local economy of importing to actually make this global product. Make sense? Okay, so that was the Big Mac story. Now we can go and look at sort of where they're, not just what they're eating and sort of that local signal that's coming from diet, but what they're drinking and where they might be coming from based on hydrogen and oxygen isotopes. So this is a sampling trip. These are 3 epic sampling trips that were part of my thesis work. You can see where we sort of flew into New Orleans and then came back to Salt Lake, and then we flew into El Paso and came back to Salt Lake, and then did a whole cross country, thousands of miles on rental cars. We had a cooler that would hold literally a dead body, and we just filled it up with food at every stop, and it was very weird. I would go into the grocery store and was like, hi, I'd like 1/16 of a pound of ground beef. And they're like, okie dokie. So these are the samples that we collected as part of that sampling trip. You're looking at, in the black dots here, supermarket ground beef. So when I was walking up to the counters and asking for these tiny little amounts from the meat counters versus the hamburgers that we were buying at different hamburger places, looking at the hydrogen isotopes versus the oxygen isotope ratios in these. And I should point out, has anyone worked with hydrogen isotopes before? Measured it? A little bit? Ever dealt with exchangeable hydrogen? Sort of the bane of everyone's existence. So these values are the non-exchangeable hydrogen isotope ratios, and we can talk more about that offline if you want to get into that Pandora's box, but I don't have it labeled correctly. It is the non-exchangeable hydrogen isotope ratio. So you can see we've got a nice spread here in hydrogen and oxygen isotope ratios for all these different samples from across the United States. And if we start sort of drilling down into this data set and we say, okay, I'm just going to look at the hamburgers, I'm going to drop out the supermarket ground beef samples, and I'm going to look at hamburgers I bought outside of Utah and those in white that I bought in the state of Utah. And you can start seeing, wow, the Utah samples sort of, a lot of them sit at this really distinctive low values, right? So if we take a look at those a little bit more closely and we say, I'm interested in the hamburgers that were purchased at local chain restaurants. So restaurants that you only find in Utah or the Intermountain West. Has anyone seen Crown Burger or Apollo Burger while you're here? Talk to me afterwards. I can send you to the best place to find a hamburger in town. And then everything in black are Burger Kings, McDonald's, Wendy's. These national chain restaurants, I just happened to visit them here in Utah. We can see again, these Utah, especially these local chain Utah hamburgers, have these really low hydrogen and oxygen isotope ratios. So where are they coming from? Well, to predict, we need a model. So here's my just quick and dirty 2011 model where we collect samples of known origin beef, and we have the hydrogen isotope ratios of those that came from these different ranches versus the water that was available to them. So here's hydrogen, and there's oxygen, so we can now predict one from the other. And we shove it into this prediction, and we take into account all this uncertainty, and we build these probability sort of functions. And we can look at 2 hamburgers in particular. So this was a local chain hamburger that I bought at a Crown Burger in downtown Salt Lake, and a Burger King that I bought on the same day a block away. Very different hydrogen and oxygen isotope ratios. And if we predict where we think the beef cattle originated, the local chain restaurant looks like it got its beef from the Intermountain West, whereas the Burger King hamburger came from not the Intermountain West. So in other words, by choosing to eat at a local Utah restaurant, I actually was eating local beef as well, which is kind of cool when you think about it, right? So this is these 2 restaurants. That's the Crown Burger. That's the Burger King. And the reason I love Crown Burger so much is because it makes the best fry sauce in the entire world. Has anyone had fry sauce yet? No? Okay, so you should go to Crown Burger while you're in town, and you should eat fry sauce, which is, don't ask what it is. It's delicious. It's so popular here. This is an Olympic pin. You know, when the Olympic Games come out, they made a fry sauce Olympic pin. That's how important it is to use. There was also a green Jell-O one, but the fry sauce Olympic pin was a pretty hot item at the time. So, fry sauce, delicious. Any questions on the hamburger stuff? And fry sauce?
Were you analyzing cooked beef or raw beef?
I'm both, actually, and then I did some cooking tests to see if I could make comparisons between the 2.
Did you come up with correct factors?
They looked close enough for me to go with it at the time, though I will say there was a paper just published last month that says, that actually cited me and was like, that may have been an oversimplification. And I was like, oh shit. But they did it like 5 years later, so it's okay. I could go back and revise these, I should. Yeah?
So in the national figure, there's nearly one, likelihood of approaching 1 on the Mexican border, then mostly desert there.
Yes, we have not actually screened this for where you would actually find beef cattle. So we could add another layer onto this and say where are cattle being produced in the United States and limit this even more. Did Jim do any of that in the forensics talk yesterday? Talk about layering? Okay, so yes, you can start layering some factors other than isotopes and really start limiting these down. This was just an isotope example.
So this is only the restaurant, it's not really where beef was produced?
No, it's just where we were predicting. So what we did was predict the drinking water for that particular cow or that particular beef sample and show where we'd expect to find that water. Whether or not there's cows actually there being raised there, that would be the second layer.